June 15, 1943. South Pacific, 100 miles northeast of Guadalcanal. The tropical morning air hung thick with moisture as Lieutenant Commander Toshio Nakamura carefully disassembled the American radio set on the makeshift workbench inside his laboratory tent. His fingers moved with delicate precision, separating each component with the reverence of a priest handling sacred relics. What the Imperial Japanese Navy could learn from this captured technology might finally explain why American forces always seemed one step ahead. "This will give us the advantage we need," Nakamura told his assistants confidently, unaware that within 3 months, his entire signals intelligence unit would be decimated precisely because of the very equipment he was studying so intently. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the untold story of how Japan's desperate race to match American radio technology inadvertently created a fatal vulnerability that would cost thousands of lives and help turn the tide in the Pacific War, revealing how technological adoption, without understanding, can transform an intended advantage into catastrophic defeat. The sound of distant aircraft caused Lieutenant Commander Nakamura to pause his work. His assistant, Ensign Hiroshi Yamada, stepped outside the tent momentarily, then returned with a shake of his head. "American patrol planes again, sir. Third time today." Nakamura nodded grimly. The Americans had been remarkably persistent lately, almost as if they knew exactly where to find Japanese positions. He returned his attention to the captured SCR-284 radio set, marveling at its sturdy construction and efficient design. "Look at the quality of these vacuum tubes, Yamada," he said, holding up a glass component carefully between his thumb and forefinger. "American industrial capacity truly is remarkable. This single radio set contains more refined materials than we can allocate to an entire platoon." The difference in manufacturing capabilities between the two nations was becoming increasingly apparent to Nakamura. Before the war, as an electrical engineering professor at Tokyo Imperial University, he had read extensively about American production methods. The reality, however, was even more impressive than the literature had suggested. Their small signals intelligence outpost, hidden on this unnamed island, had been established 2 months earlier with a critical mission: to understand and possibly replicate American communication technology. Admiral Isoroku Yamamoto himself had authorized the special unit. After continued naval defeats suggested American forces were somehow anticipating Japanese movements. Yamada leaned over the disassembled radio. "The crystal oscillator design is unlike anything in our equipment, sir," Nakamura agreed. "Their frequency stability is exceptional. Our sets drift too much in this humidity." What neither man yet realized was that the very equipment they were studying contained elements that would soon lead to their discovery. 500 miles to the southeast, aboard the USS Constellation, Lieutenant James Wilson reviewed the latest intercept reports with growing excitement. The young communications officer had been tracking unusual radio transmissions for weeks. "Captain, we've got another one," Wilson reported, handing a sheet of paper to Captain Robert Harrington. "Same frequency harmonics as before. I'm certain it's one of those modified transmitters we've been hunting." Captain Harrington studied the report. At 52 years old, with salt and pepper hair and deep lines etched into his weathered face, Harrington had seen enough action to trust the instincts of specialists like Wilson. "Location?" he asked. "Triangulation puts it about 100 miles northeast of Guadalcanal. The signal's consistent with our intelligence about their new signals research unit." Harrington nodded thoughtfully. Naval intelligence had been tracking rumors of a specialized Japanese technical unit for months. If Wilson was right, they might have finally located it. "How confident are you about this, Lieutenant?" Wilson straightened. "Very confident, sir. The Japanese are using American radio components, but they're operating them incorrectly. They're generating harmonic frequencies they don't seem to realize are detectable. It's like they're inadvertently broadcasting a beacon." "And you believe this is their signals intelligence team, the one studying our equipment?" "Yes, sir. The transmission patterns match what we'd expect from technical testing rather than regular communications. They're methodically cycling through frequencies, testing power levels. They're studying the equipment, not just using it." Harrington considered this information. If a Japanese technical intelligence unit was indeed operating in that area, neutralizing it could provide a significant advantage. Draft a report for command. I want satellite reconnaissance of that area immediately, Harrington ordered. And Wilson, good work. Keep monitoring those transmissions. Back on the island, Nakamura and his team were making what they considered remarkable progress. They had successfully reconstructed 3 American radio sets, using a combination of captured components and modified Japanese parts. The hybrid devices appeared to function adequately, though they required frequent adjustments. Chief Petty Officer Kenji Tanaka, the team's most experienced radio operator, frowned as he tuned one of the modified sets. "The signal keeps drifting, sir. I can compensate manually, but it's not holding stable like the original American equipment." Nakamura sighed. This had been a persistent problem. The Americans use higher-grade quartz for their crystal oscillators. Our substitutes aren't precise enough. The technical challenges were formidable, but Nakamura felt they were gradually overcoming them. What troubled him more was the increasing frequency of American aerial patrols. Twice in the past week, they had been forced to cease operations and conceal their equipment as aircraft flew directly overhead. "It's almost as if they know we're here," Yamada remarked one evening as the team ate their rations of rice and dried fish. Nakamura dismissed the concern. "Impossible. We maintain strict radio silence except for our scheduled transmissions, and those are encrypted using our newest naval codes." Lieutenant Shigeru Ishikawa, the unit's security officer, wasn't so certain. "With respect, Commander, something has changed. The patrol patterns are too precise. They're focusing directly on this area." Nakamura considered this. "Perhaps we should relocate as a precaution." "That would set our work back by weeks," Yamada objected. After careful deliberation, Nakamura decided they would remain but enhance their concealment measures and further restrict their test transmissions. It was a decision he would soon regret. At Pearl Harbor, Commander Joseph Sullivan of the Office of Naval Intelligence reviewed the latest reports with growing interest. At 43, Sullivan had spent the past decade specializing in signals intelligence. The war had transformed his academic expertise into a vital military asset. "This is extraordinary," he told his assistant, Lieutenant Sarah Henderson. "The Japanese are essentially painting targets on themselves." Henderson, one of the few female officers in such a sensitive position, had earned her role through exceptional analytical abilities. She had been among the first to notice the pattern in Japanese transmissions. "They're clearly testing equipment they don't fully understand," she replied. "Our radio designs include harmonic suppressors, specifically to prevent detection. The Japanese have either removed these components or don't recognize their purpose." Sullivan nodded. "And every time they transmit, they're broadcasting their location on multiple frequency bands. Have you briefed Admiral Nimitz on this?" "Yes, sir. He's authorized Operation Lighthouse to proceed. The Catalina squadrons have been given the coordinates and will begin intensive reconnaissance tomorrow." "Excellent. And what about our counterintelligence measures?" Henderson handed him another folder. "We've implemented your recommendation. We're now deliberately including non-functional harmonic suppressors in any equipment likely to be captured. They look identical to the real components, but actually amplify the harmonic emissions." Sullivan smiled. "So if they do capture more of our radios, they'll be even easier to track," Henderson finished. The following morning, Nakamura authorized a series of test transmissions using their modified equipment. They needed to determine if their latest adjustments had improved frequency stability. The team worked methodically, documenting signal strength and clarity at various power settings. Chief Tanaka operated the main set, while Yamada recorded measurements and Nakamura observed. They were encouraged by the initial results. "The signal's holding much better today," Tanaka reported. "The new crystal mounting design seems to be working." Nakamura allowed himself a moment of satisfaction. After weeks of frustration, they were finally making progress. If they could reliably reproduce American radio performance, it would significantly enhance Japanese communication capabilities throughout the Pacific Theater. Little did they know that each transmission was being detected by American listening posts hundreds of miles away, with precise bearings being calculated and reported. 3 days later, the first American reconnaissance aircraft appeared directly overhead. It was a PBY Catalina flying boat cruising at medium altitude. Rather than the usual patrol pattern, this aircraft circled their position repeatedly. Lieutenant Ishikawa rushed into the laboratory tent. "Commander, we need to suspend operations immediately. That American aircraft is photographing the area." Nakamura quickly ordered all equipment to be concealed and personnel to take cover in the emergency bunkers they had constructed. For 2 hours, they waited as the aircraft continued its methodical surveillance. When it finally departed, Nakamura called his officers together. "This is no longer coincidental. They appear to have located our position." "But how?" Yamada asked, bewildered. "We've maintained strict protocols. Our camp is well camouflaged." Nakamura had no answer, but a growing suspicion was forming in his mind. "From now on, we will cease all test transmissions. Communication with headquarters will be conducted only via the standard Japanese equipment, not our modified sets." The precaution came too late. The Americans now had confirmation of what their signals intelligence had suggested. Aboard the USS Enterprise, Admiral William Bull Halsey reviewed the reconnaissance photographs with his staff. The images clearly showed a small but sophisticated Japanese installation, carefully concealed beneath camouflage netting, but visible to aerial photography. "What exactly are we looking at, Commander?" Halsey asked his intelligence officer. Commander David Thompson pointed to several structures. "Based on the equipment visible and the antenna configurations, this appears to be a specialized technical intelligence unit, sir. Most likely studying our communication systems." Halsey understood the implications immediately. If they successfully reverse engineer our radio technology, it could eliminate one of our significant advantages. "Yes, sir. And more concerning, if they identify the vulnerabilities in their own systems that we've been exploiting, our intelligence advantage could be compromised." The decision was swift. "Prepare a strike package. I want that facility and all its personnel eliminated." Thompson hesitated. "Sir, capturing their research intact could provide valuable intelligence about what they've learned." Halsey considered this briefly. "Too risky. If they've made breakthroughs we're not aware of, I don't want that information potentially escaping during an extraction operation. Complete destruction is the safest option." 2 days later, Nakamura was awakened before dawn by the sound of distant aircraft engines. This was different from the previous reconnaissance flights, more engines approaching fast. He had barely pulled on his uniform when the first explosions shook the camp. Lieutenant Ishikawa burst into his quarters. "American bombers, sir. At least 12 aircraft." Nakamura rushed outside to witness devastation unfolding around him. American dive bombers were delivering remarkably precise attacks on their installation. The main research tent received a direct hit just as he watched, equipment and documents instantly consumed by flames. "Get everyone to the shelters," he ordered, though he knew their hastily constructed bunkers would provide little protection against such an assault. As he ran toward the communication bunker, hoping to send a final warning to headquarters, a realization struck him with horrifying clarity. He stopped abruptly, causing Ishikawa to nearly collide with him. "The radios," Nakamura said, his voice barely audible above the explosions. "It's the radios." "Sir?" Ishikawa looked confused. "The American equipment we've been testing. Somehow they can track it. The pieces suddenly fit together. The increasingly precise patrols, the focused reconnaissance, and now this perfectly targeted attack." Before he could explain further, another bomb found its mark. Neither officer would survive to report their discovery. The strike was devastatingly effective. Within 20 minutes, the entire Japanese facility was destroyed, with no survivors and minimal evidence remaining of its purpose. The American bombers returned to their carrier without losing a single aircraft. In the aftermath, Admiral Chester Nimitz received the preliminary report with satisfaction. "How many similar Japanese technical units have we identified?" he asked Commander Sullivan. "At least 3 others, Admiral, all studying different aspects of our technology." "And they're all making the same mistake?" Sullivan nodded. "Yes, sir. They're so focused on replicating our equipment's performance that they're overlooking the defensive measures we build into our designs. Each time they test their modified versions, they're broadcasting their positions. Nimitz allowed himself a rare smile. Ensure this remains closely guarded. I don't want the Japanese realizing why we can locate their special technical units so easily. Understood, Admiral. The success against Nakamura's team was just the beginning. Over the next 4 months, American forces would systematically locate and neutralize Japanese technical intelligence units throughout the Pacific, dealing a crippling blow to their ability to close the technological gap. In Tokyo, Imperial Japanese Navy headquarters noticed the disturbing pattern, but struggled to identify the cause. An emergency meeting of senior technical officers was convened to address the crisis. Admiral Takeo Kurita addressed the assembled officers gravely. We have lost 4 specialized technical intelligence teams in the past 3 months. All were studying American equipment. All were discovered despite extensive security measures. We must determine how this is happening. Captain Mitsuo Fuchida, who had led the attack on Pearl Harbor and now served in naval intelligence, offered his assessment. The Americans must have some method of tracking their own equipment, even when captured. That's impossible, objected Captain Sadatoshi Tomioka, head of the operations section. We've thoroughly examined all captured equipment for tracking devices. There are none. Then it must be something more subtle, Fuchida insisted. Perhaps a characteristic in the equipment itself that we're overlooking. The debate continued without resolution. The Japanese Navy simply lacked the technical background to identify the principle of harmonic suppression that was so fundamental to American radio design. In a small signals laboratory in San Diego, California, Lieutenant Sarah Henderson had been reassigned to work with a special engineering team developing the next generation of capture-safe equipment. Their mission was to design communication devices that would be even more traceable if captured and studied by enemy forces while appearing perfectly normal. The Japanese still haven't figured it out, she told Professor Edwin Armstrong, the renowned radio engineer who had been brought in as a civilian consultant. They continue to test modified American equipment, and we continue to locate and neutralize their facilities. Armstrong, the inventor of FM radio technology, nodded thoughtfully. It's not surprising. The concept of harmonic suppression isn't obvious unless you're specifically looking for it. To them, they're simply trying to replicate a working radio. They don't realize that every transmission creates harmonic frequencies that can be detected hundreds of miles away. How long do you think this advantage will last? Henderson asked. Armstrong considered the question. Until someone who truly understands radio propagation theory examines the problem. Their Navy has good engineers, but they're working under terrible constraints, limited access to materials, pressure to produce results quickly, and now the constant threat of being targeted. It's not an environment conducive to theoretical insights. Henderson showed him the schematics for their latest design. We've modified the oscillator circuit to generate even stronger harmonics on specific frequencies. If they build this, we'll be able to detect them from twice the current range. Armstrong studied the design with professional appreciation. Elegant, and they'll never notice because the primary frequency will function perfectly. He paused, then added reflectively, It's a cruel deception in a way. They're being punished for trying to learn. Henderson's expression hardened slightly. They started this war, Professor. We're using their eagerness for our technology against them. By early 1944, the Japanese had begun to suspect something was wrong with their approach to studying American equipment. After losing several more technical teams under mysterious circumstances, Imperial headquarters issued new directives. Captured American communication equipment was to be transported to mainland Japan for study, rather than examined in the field. This change in procedure stemmed from a breakthrough by Professor Hideki Yagi at Osaka Imperial University, the inventor of the directional Yagi antenna. After examining fragments of American radio equipment recovered from destroyed outposts, he identified the harmonic suppression components and recognized their purpose. In a classified report to the Imperial Navy, Professor Yagi explained, American radio designs incorporate sophisticated filtering circuits specifically to prevent the generation of harmonic frequencies. When our technicians remove or modify these components, They inadvertently create distinctive signal patterns that can be detected at great distances. Each modified radio effectively becomes a beacon announcing its location. The report sent shockwaves through Japanese high command. For months, they had been inadvertently compromising their own security through their study of American technology. Worse, they had lost some of their best technical minds in the process. New protocols were immediately established. American equipment would henceforth be studied only in secure mainland facilities with specialized shielding. In the field, soldiers and sailors were explicitly forbidden from modifying captured radios or attempting to reverse engineer them. The damage, however, had already been done. Japan had lost precious time and expertise in the race to match American communication capabilities. The technological gap, already significant at the start of the war, had widened further. In Washington, D.C., too, the Office of Naval Intelligence monitored these developments with interest. They noted the sudden cessation of detectable harmonic transmissions from Japanese forward areas. They finally figured it out, Commander Sullivan informed Admiral Ernest King, Chief of Naval Operations. King, known for his stern demeanor, merely nodded. How much did it cost them before they did? We estimate they lost approximately 120 technical specialists, including some of their best communications engineers, plus all the research data and equipment at those facilities. And our next move? Sullivan outlined the contingency plan that had been prepared for this eventuality. We've already modified our equipment capture protocols. Any communication devices likely to fall into enemy hands now contain even more subtle technical traps. Different frequencies, different principles, but the same result. If they study them, we'll know. King approved the plan without hesitation. In the technological chess game that paralleled the physical battles of the Pacific War, America had secured another advantage. As the war progressed into 1945, the Japanese found themselves increasingly outmatched in the realm of electronic warfare. Their inability to close the technological gap had profound consequences for their military effectiveness. Major General Curtis LeMay, commanding the 21st Bomber Command, leveraged this advantage ruthlessly. American bombers routinely jammed Japanese radar and communications while maintaining their own secure coordination. The resulting air superiority accelerated Japan's defeat. In a bitter irony, the very effort to catch up technologically had hastened Japan's downfall. The resources devoted to studying American equipment and the expertise lost when those efforts were detected and neutralized might have been better applied to developing original Japanese solutions. After the war concluded, the full story of this technological deception remained classified for decades. It was only in the 1970s that details began to emerge through declassified documents and the memoirs of participants. James Wilson, who had risen to the rank of captain by war's end, wrote in his 1978 memoir, "The Japanese never fully appreciated that we had designed our equipment not just to work well, but to fail in specific ways if tampered with. Their focus on replicating our technology blinded them to the traps we had incorporated. In their eagerness to learn our secrets, they revealed their own positions." The story of Lieutenant Commander Nakamura and his doomed signals intelligence team would eventually be reconstructed through captured Japanese records and American after-action reports. Their fate illustrated a fundamental lesson about technology adoption. Understanding the principles behind a technology is more important than merely replicating its functions. For the Americans, the success of their deception confirmed the value of thinking beyond primary functionality when designing military equipment. Future generations of American military technology would incorporate similar capture-aware features designed to maintain advantages even when the equipment fell into enemy hands. Sarah Henderson, who continued her career in naval intelligence after the war and eventually reached the rank of captain, would later train a new generation of communications specialists. Her core teaching principle, derived from the Pacific War experience, was straightforward. Always assume your equipment will be captured and studied. Design it accordingly. The technological disparity between America and Japan had been evident from the war's beginning, but few appreciated how cunningly that disparity would be exploited. American industrial capacity produced not just more equipment, but more sophisticated equipment, designed with multiple layers of purpose. The Japanese engineers who eagerly disassembled, captured American radios, were looking for technological secrets. What they failed to recognize were the counterintelligence measures embedded within those very technologies, measures that turned their pursuit of knowledge into a fatal vulnerability. As the sun set over the Pacific on August 15, 1945, the day of Japan's surrender, Admiral Nimitz stood on the deck of the USS Missouri, reflecting on the many factors that had contributed to Allied victory. Among them was the quiet triumph of American technical ingenuity, not just in creating superior technology, but in ensuring that this technology served American interests even when in enemy hands. The lesson had been learned at great cost to the Japanese. In the modern era of warfare, understanding the deeper principles of technology was as important as possessing the technology itself. It was a lesson future military powers would strive never to forget. In the decades following the war, this episode would be studied at military academies worldwide as a classic example of technical counterintelligence. The practice of incorporating hidden features in military equipment, features that activate only when the equipment is being studied or reverse engineered, became standard procedure for advanced military powers. Today, as we consider this historical episode, we might reflect on its broader implications. Technology transfer is never merely about hardware or software. It encompasses knowledge, understanding, and context. Without these elements, technology can become not an asset, but a liability, as Lieutenant Commander Nakamura and his team learned too late. Their story serves as a reminder that in the complex interplay of warfare and technology, appearances can be deceiving. Sometimes what seems like a valuable capture is in reality a carefully crafted trap. And sometimes the most important components of a technology are not the ones you can see when you take it apart, but the principles and purposes that guided its design from the beginning. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.